You stare at the page. The numbers blur, the logic refuses to click, and the pencil snaps. It is the universal wall we hit when an equation feels like a barrier rather than a tool. In that moment of intense friction, every student asks the same question: why endure this? You likely won't need to solve for X to navigate a grocery store or manage a bank account, but the value of the equation lies in the resistance it provides. When you struggle to bridge two logical points, your brain initiates a biological workout. Research into the gymnastics of the mind shows that our brains use the same neural pathways to manipulate cold mathematical information as they do to regulate hot emotional responses. Both require the ability to update and hold on to new information under pressure. This means that failing a problem and trying again is a functional necessity. The effort required to solve the math strengthens the cognitive circuits used to process complex feelings and build emotional resilience. The Duke neurogenetic study and cognitive research from Oxford have documented how this internal friction physically alters the brain structure. Mathematical thinking increases gray matter in the prefrontal cortex, the region responsible for complex thought, planning, and impulse control. This growth enhances working memory. By forcing the brain to recognize patterns and hold multiple variables at once, you physically expand its ability to manipulate data. Because the prefrontal cortex governs our ability to regulate emotions, this physical development provides a structural advantage. Practicing adaptation in the controlled environment of a math problem trains the brain to treat real-world uncertainty as a solvable puzzle rather than a threat. Long before it is applied to the outside world, mathematics serves as a cognitive gym, building the mental endurance required for emotional health. Once the human mind was rewired by this logic, we began projecting that internal order onto our surroundings, inventing the architecture of civilization. We see this in ancient Indian monuments, where buildings used fractal geometry and trigonometry to seed repeating, perfect symmetry into massive stone structures. This structural logic also dictates auditory beauty. The compositions of Bach rely on these same ratios and intervals, using mathematical symmetry to organize sound into art. Today, this ability to break down patterns and represent them symbolically forms the framework for the modern technological revolution. Mathematics is the bridge between human imagination and physical reality, defining both our historic masterpieces and our digital future. This connection is documented in research on artificial intelligence. As this paper from JETIR explains, AI functions through linear algebra, using matrices to represent and process information in neural networks. To simulate human reasoning and self-correction, these systems rely on calculus, probability, and statistics. These tools allow machines to model randomness and minimize errors. In a process called gradient descent, calculus is used to optimize these models. By calculating derivatives, the system identifies the most efficient path to the lowest possible error rate in its predictions. Mastering these mathematical concepts means mastering the source code that drives the artificial intelligence revolution. A moment of wonder. This code extends beyond human technology. We find these exact mathematical structures pre-written into the natural universe. Our species is physically bound to our solar system. We cannot travel to a black hole's event horizon or witness the birth of a star in a distant nebula. Yet, through mathematics, we decode these forces. We use these equations to predict gravity, light, and energy across the cosmos, exploring the universe from behind a desk. Mathematics provides a shared framework between our logic and the stars, allowing us to verify the existence of things we can never touch. This returns us to the desk, the notebook, and the difficult equation from Act 1. This initial frustration is a sign of growth. You are fortifying your emotional resilience, participating in human innovation, and wielding the language of the cosmos. The struggle of learning mathematics is the ultimate act of human empowerment, a direct connection to the underlying